A primary pillar that supports deep time in the scientific community is radioisotope dating. Our guest shows that radioisotope methods used to date the rocks are flawed. He'll expose the single assumption that causes these methods to falsely yield ages of millions and billions of years, when in fact, the actual ages are on the order of only thousands of years. Coming up on today's edition of Origins, Deep Time, Deep Deception, Part 2, with Dr. John Baumgardner. Hello and welcome to Origins. I'm Ray Heiple. It's an honor to be your host today. During this program, we showcase interesting guests who present evidence from science along with other important facts validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. John Baumgardner, is Research Professor Emeritus in the School of Engineering at Liberty University. He has a PhD in geophysics from UCLA and worked at Los Alamos National Laboratory in computational physics during most of his scientific career. Since the early 1980s, he has provided most of the primary research on the concept of catastrophic plate tectonics in connection with Noah's flood. He was also a part of the RATE team, which discovered radioisotope evidence that the Earth is young. Welcome to the program, John.
Thank you, Ray.
We are looking at Deep Time, Deep Deception, Part 2. In Part 1, we looked at things like the importance of this topic, and why don't you go ahead and just take it from there?
Okay. In Part 1, we saw how the concept of deep time makes nonsense of Genesis 1 to 11 and transfers the accounts of Adam and Eve and Noah from history to the realm of allegory. In so doing, it has all but destroyed the authority of the Bible in the minds of most educated people today.
So we mean deep time, millions and billions of years for the age of the earth versus the 6,000 years of the Bible.
That's right. That's right. So this is the team that basically was assembled by the Institute for Creation Research in 1997. And the 7 PhD scientists that did the research are in the front 2 rows here.
Okay.
We also reviewed a key finding of the RATE team, namely that significant levels of C14 are present in all carbon-containing fossils throughout the rock record. One thing I failed to mention in that Part 1 is that the team also found C14 in diamonds, which is a staggering result because diamonds are supposedly several billion years old, and finding C14, which has a half-life of only a few thousand years, is simply unthinkable if those diamonds are really billions of years old.
John, was that the first time that carbon-14 was identified in diamonds?
Very first time. No one had even thought of analyzing diamonds for C14.
What was the reaction in the secular community to that finding?
Largely unbelief. They just could not imagine it. But after we measured our C14, a secular lab in California checked diamonds for C14, and they found the same results that we had reported. They found the same levels of C14 in their diamonds as we found in ours.
So I'm sure they've adjusted their dating methods and say the Earth is only a few thousand years old, right?
Yeah, of course.
Another example of contamination.
Yeah, they just passed it off as contamination.
Contamination.
This finding of C14 in essentially all fossils implies that these fossils are merely thousands of years old and not millions or hundreds of millions of years. In other words, C14 is now our friend.
That's significant because so oftentimes Christians will be told, well, carbon-14 proves that the Earth is millions of years old when actually it's quite the opposite.
That's right. Now in this program, I would like to deal with another big issue, and that is, why do other radioisotope methods give such vast ages in the range of millions to billions of years when applied to the Earth's rocks?
Okay, so carbon-14 we've taken care of, but there are other ways they measure.
That's right.
We've got to look at those too.
Yeah. So the rate approach, the approach that our team used on this topic, was to face up to the reality that most of the Earth's rocks do indeed actually contain millions to billions of years worth of nuclear decay products, not merely a few thousand years worth. So our task was to understand in an objective way why such high levels of nuclear decay products exist, given that, according to the Bible, the history of the world since creation spans only a few thousand years.
John, I think that's an important point, that your team took the data as it is there and didn't try to deny it, but said, well, wait a minute, let's really look at maybe why or what other factors could account for this.
That's right. Now, let's take a quick look at the assumptions that are made when these radioisotope methods are applied to a rock. The first assumption is that the rock sample has remained a closed system since the rock cooled from a molten state. In other words, neither parent isotope or daughter isotope has leached out or leached into the sample. It's been a closed system.
Okay.
That's the first assumption. Second assumption is that the initial amounts of daughter products can be known accurately. That there's some way of estimating accurately what the original amount of daughter product was.
Okay, they assume this as well. Okay.
Okay. The third assumption is that the nuclear decay rates have remained unchanged throughout Earth history. Now, the validity of the first two of these assumptions for a given rock body can be checked or tested by applying what is called the Isochron Method. I'm not going to go into that, but there is a way to determine whether or not those first two assumptions are true or not.
And what does it turn out?
If it fails to pass that test, generally that rock is not used for dating.
So that's a corrupt rock or the system somehow. But this test then says, hey, these assumptions really are valid at this point.
Generally speaking.
Well, that
yes.
leaves the third then.
All right. So what about the third assumption, namely that the nuclear decay rates have remained unchanged throughout Earth history? Well, that brings me to a breakthrough rate finding. We found that nuclear decay rates have not been constant throughout Earth history. Instead, during brief episodes in the past, they have been drastically higher than they are measured to be today.
I assume you're going to show us how you found that.
Right. Just what sort of research led us to such an astonishing conclusion? Well, first of all, it involved tiny crystals known as zircons. Here's the chemical formula, ZrSiO4, zirconium silicate, which are commonly found in granite. This is a microscope photograph of some zircons that we actually isolated in our research. And as I said, these are common in granite. Just some facts about zircons. It turns out that uranium atoms substitute readily for zirconium atoms in the crystal. So zircons tend to incorporate up to about 1% uranium when they form. In other words, these zircons are radioactive. Zircons tend strongly to exclude lead, a uranium decay product, when they form. So we can, with confidence, assume that the lead concentration when these zircons formed was 0. So that helps us with that second assumption.
That's sort of a check on that assumption. That's very good.
And thirdly, zircons are very stable. They have a very high melting temperature, mechanically are extremely hard, and hence are extremely resistant to weathering and alteration.
So this would speak to the fact that this is probably, or more oftentimes than not, a very stable and incorruptible way of checking these things, correct?
So that it's reliable.
Reliable.
You can assume that they've, in most cases, have been a closed system. So these two things relate to those first two assumptions. The zircons we studied were from a drill core from a 2.5 mile deep hole in granite in northern New Mexico, in this area of New Mexico. And that's the drill rig that was used, and this represents some of the zircons that we extracted. Now, uranium decay in zircon yields two stable end products. Lead, if you start with uranium-238, decays to lead-206, and helium. In the process of decaying from U-238 to lead-206, there are 8 alpha particles emitted in that chain of decay steps. And these almost instantly turn into helium atoms as they capture 2 electrons from the environment. But just as helium leaks out of a party balloon, in a similar way, it also leaks out of a zircon crystal. So helium migrates or diffuses through the zircon into the surrounding environment. Most often zircons are embedded in another crystal of biotite, and so over time the helium tends to leak out of the zircon into the surrounding crystal.
So you can test that by measuring how much remains in the zircon.
Right. It was found that large amounts, tens of percents of the helium from all the uranium decay was still retained in the zircons in this drill core. A scientist by the name of Robert Gentry in the early 1980s did these experiments to measure the helium retention, and he found these black numbers are his measurements, up to 58% of all the helium in 1.5 billion years worth of uranium decay were still in the crystal. The uranium lead age for these crystals was 1.5 billion years based on how much lead was present.
Okay.
And also based on the current rate of decay of uranium. Okay, and in our work we measured 2 other samples from the same drill core, and one case at a slightly shallower depth where the temperature was lower, we found 80% of the helium present, and the other, which was at 1.4 kilometers, measured 42% present. So these are astonishing levels of helium retention in these tiny zircon.
John, there seems to be a consistency as well, that the shallower you go, the higher the number, the deeper you go, the lower the number.
Yeah, there's a good reason for that. The rate that it leaks out of a crystal depends strongly on the temperature. So as you go, we went deeper in the hole, the temperature got higher, and at these high temperatures it leaks out faster, so there's less of it left in the crystal. We were aware how fast helium migrates through many other solids, and based on that, we were confident that the helium would have all leaked out of these zircons were they truly 1.5 billion years old. Yet without knowing the actual migration rate of helium in zircon, we could not make a strong case that they were dramatically younger than that 1.5 billion years. We therefore launched a major initiative to measure the helium diffusion rate in zircon in an accurate way. So we obtained samples from the same core that Dr. Gentry had studied and extracted 1,200 zircons in the same size range. I, working at Los Alamos, was able to get access to the cores that were still stored there, got samples from 750 meters deep and 1,500 meters deep in the core. We took these samples to the Institute for Creation Research, crushed them, separated the minerals, and then the final step, we had the zircons in a certain size range, very narrow size range, extracted at a lab called Activation Laboratories in Canada. Okay, and here's some of the zircons that we got from those cores. This is an electron microscope image, an optical microscope image. These were all within a narrow size range of 50 to 75 microns. That's approximately the diameter of a human hair. Okay, and then we contracted with the world's leading expert in measuring helium diffusion for us. And this was just a sketch of the apparatus he used. The researcher did not know who the sponsor was. Our goals are the site from which the samples were obtained.
And why is that important, John?
Well, the reason is that the measurements were unbiased by any of these issues.
So what you got then was someone just taking the rocks that you sent them, running them through the apparatus, and then telling you what the results were.
That's right.
There was no objective, there was no bias, or he just said, hey, these are the results.
Yes.
That's what you want.
But prior to sending them for analysis, we did some predictions, which we published three years before the measurements were made. We predicted what the diffusivity would be if the samples were only 6,000 years old.
Okay.
And also what the diffusivity ought to be if they were 1.5 billion years old.
Which is what the other method said that they were,
Right.
the other radioisotope
Right.
method.
And so there was a difference of about 100,000 between these two predictions. And we felt that the measurements would easily distinguish which one of these was closer to the truth.
Because that factor of 100,000 is a very large figure we're talking about.
That's right. So we just could hardly believe it when we got the results back. The results fit this 6,000-year curve within the 95% confidence limits of the measurements.
And these are the results given to you by the world's leading expert.
That's right.
In measuring this.
That's right. Astonishing finding. The measured diffusion rates fit the 6,000-year prediction within the 95% confidence limits.
Now this is what good science is. You make a theory, you do an experiment, the experiment backs up the theory overwhelmingly. You've got pretty solid ground now in saying, hey, this theory shows itself to be true.
Yeah. These are truly
Welcome back to Origins. We're talking to Dr. John Baumgardner, who's been sharing about Deep Time, Deep Deception, Part 2. John, we left off by showing your team's, the rate team's estimate of a 6,000-year dating for these rocks, the diffusion rate of helium from zircon being confirmed 95%.
Right.
What are the significance?
Well, the issue here is how could most of 1.5 billion years worth of the helium still be inside these zircons when the direct laboratory measurements of the helium migration rate show that most of that helium ought to have escaped in just a few thousand years. So that's the issue.
That's the question.
That's the question. To express it in a slightly different way, we have two clocks, as it were, in zircon, each based on a distinctly separate physical process, which these two clocks disagree by a factor of 250,000 in their age. What's the conflict? So with the helium diffusion, we get an age of 6,000 plus or minus 2,000 years. With the uranium nuclear decay clock, based on the the rate of uranium decay we measure today in the laboratory, we get an age of 1.5 billion years. So which clock, if either, is correct? What's responsible for this discrepancy? Well, our answer, based on some of the other rate projects we undertook, is that it's the helium clock that is the correct one. And that the reason for the large age of the uranium decay clock is that nuclear decay rates were much higher in the past, during brief intervals in the past, compared with today. Our study of helium retention in zircon showed 1.5 billion years worth of nuclear decay had occurred within the last 4,000 to 8,000 years. And we concluded that this means that nuclear decay rates have not been constant and the same as measured today, but instead have been dramatically higher during brief episodes in the past. We believe these episodes were during creation week, early in creation week, before there was any life on Earth, and then also during the flood.
And this would refute that third assumption that the rate has always been constant,
right.
Which would assume the conditions were always the same, and the uniformitarianism that we hear sometimes.
That's right. So where the error was that we were looking for, it's the error in that third assumption that nuclear decay rates have always been what we measure them to be today.
And your clock, the rate of that helium coming out of the zircon, as it were, that is showing that this is actually correct.
Yes, and this, of course, is a profoundly significant result. Two other rate projects pointed strongly to this same conclusion. So an immediate implication is that radioisotope dates based on the assumption of constant nuclear decay rates are in error by large factors, in some cases by factors exceeding 500,000. So it means the standard radioisotope methods for dating rocks are have huge errors associated with them.
And you have the tests of the helium, the carbon-14 in diamonds. I mean, some significant experiments showing that these dates are, in fact, in error.
Yes. A key consequence is that the concept of deep time, grounded upon the assumption of invariant nuclear decay rates, is simply invalid. Those who hold the Bible to be God's Word, hence, no longer need to be intimidated by the deep deception of deep time.
And I like the way you used science to show this is the case. This isn't, as so often people do, divorcing faith from reason or fact from the Bible, but we're saying, hey, let's look at these things. Let's really examine them. Let's take into account other ways of measuring them, and let's try to go where the evidence leads.
Right.
So, John, when the rate project ended, what was the response of the secular community to your findings?
Well, there were a handful of people that wanted to challenge us. So they challenged some details of our methods. And we answered those critiques very quickly, very solidly. And so once that happened, there was essentially just silence. They tried to ignore us. They've tried to ignore it, tried not to draw attention to it.
So they tried, at least an initial effort, to try to maybe poke holes in it. You guys showed that that wasn't the case, and now
silence.
Maybe it didn't happen. We'll pretend like rate never happened.
Well, I want to just give one other indicator that the radioisotope timescale is in serious error, and that is the finding of soft tissue in so many fossils from deep within the fossil record. For example, flexible blood vessels containing red blood cells preserved in a T-Rex femur that was reported in Science in 2005 by Mary Schweitzer. Photograph of the flexible blood vessels and the red blood cells.
Well, thanks a lot for being with us, John. This truly has been a wonderful program and some fascinating information that I hope our audience will follow up on.
Thank you. Thank you.
I want to thank you for joining us on this program. We looked at how using radioisotope methods, secular scientists have concluded that the rocks in the earth are over 1 billion years old. And yet the RATE team, using some other methods, carbon-14 and the diffusion rate of helium from zircon, have shown that actually the rocks, those same rocks, are only a few thousand years old. Well, it just goes to show you once again that we know what the Bible says is true, and the proof is all around you. I want to thank you for joining us for this episode of Origins, and I'd like to remind you that the programs that you see that we do here take a lot of time, it takes a lot of people and money to put together, and if you enjoy these programs, we could use your support. Won't you consider being a part of our team to regularly pray for us and to financially support us so that together we can continue to show how awesome our Creator is. And we'll see you next time.
Thank you for watching this edition of Origins. For a DVD of this program, you can order online or send a $12 donation to cover shipping and handling and write to Origins, program number 2002, Cornerstone Network, Wall, Pennsylvania 15148.
This presentation was made possible by the faithful prayers and financial support of you, our Cornerstone family.